Hello, thank you for attending to today's RSA webinar. My name is Rafał Gawenda and I will be running today's presentations together with my colleague Artur Kosakowski. The topic of this webinar is Results Connect, Robot API and the Dynamo. You can find information about our new series of robot webinars under these links. Let me remind you about the concept of RSA webinars. We will focus on the one of several topics in order to discuss issues frequently submitted to the support team. We will begin with the general introduction of selected features of the program and develop these subjects further based on the feedback we will receive from you after each of presentation. Please mind that these webinars are not supposed to be training sessions. The topic of today's webinar is Results Connect API of Robot and Dynamo. We will make introduction to Results Connect API of Robot and Dynamo and show capabilities of these tools and how to access and use them. The topic of next webinar is Revit Robot Interoperability. Seizing the opportunity, I would like to introduce to you AUTODESK Knowledge Network site, where you can find useful articles on the topics covered during this webinar, as well as on many others. Results Connect is an application that allows designers and engineers using robot structural analysis to seamlessly access data and results with Microsoft Office Excel. Results Connect is fully integrated with Microsoft Excel as an add-in. It's not required to have programming skills or knowledge of Robot Structural Analysis API to extract data for use in spreadsheets. Each formula takes as arguments a set of parameters that can be written directly inside the formula, which may come from specific cells or from and active selections within the robot structural analysis. Once the list has been made with Results Connect, data is available for post-processing in Excel. With this approach, Results Connect enables a dynamic link between robot and Microsoft Excel, eliminates copy-paste or CSV import-export steps. Results Connect is automatically installed with Robot Structural Analysis 2016. It is available on additional tab, Results Connect, added to Excel ribbon by Robot Installation. To get any data from Robot to Excel, it is required to use formulas in similar way like in standard Excel functions are used. After activating cell where the data should be imported, Formula Wizard can be used. Or, after selecting formula, Insert button or FX button to access formula can be used also. Here's the short video how to play with Results Connect. So on this short example, we will look how to import some data on selections. So first we will fill second and third column with the coordinates of nodal coordinates using wizard. So as you may see, we started the wizard from formula wizard button, then selecting nodal data, selecting node number, and then specifying to which cell we should add the data. And then, as you may see, you can adjust the formula in the same way as it can be done in Excel, every Excel formula. So selecting, pasting to different cells. Retrieving results in next columns. Here you can see how to retrieve load cases, load case names. It's very simple and intuitive, a very fast connection between Excel and robot. So now we will import reactions depending on node number, case number, by specifying different cells. Then after adjusting formula, we can easily get results as we need. So in this way, by pasting or expanding data to different columns, we can fill the data. In Excel, then we can do with the results whatever we like, what Excel can do. There are some hints, because as the formulas works on a single object selection, to be able to automatize work with results connect and robot, the arrays are implemented. So after selection in the robot, we can use formula wizard and then, for example, use arrays, select type of object, and then activate the checkbox underneath and insert button. Then program will fill the whole selection in cells one by one below another. So it will help us later on to use Results Connect. Let's make a live demo now. So I will go to Excel and also let's load the model. So I have the model prepared. I will select only bars for our consideration. So let's assume I want to get some data for these selected bars. So let's go back to Excel, and let's say in the field in the column A, I will import the selected node numbers, bar numbers. So I will use the wizard. So after pressing formula wizard, I will use the array of selected object bars. Then I will select set of range and then insert. So all the numbers from the selection are filled here. So now we can play in each row with one single bar, data bar results. So let's say in the column B, we want to add some, let's say, section names. So after activating B field, I may use now insert formula. And okay, not this one. So from here I should use bar data formula. Also, instead of length, let's say we will use section, and then we have to show bar number. After pressing apply, programmer will automatically get this data, and then by filling all these cells, program automatically will load sections from these bars. How to retrieve, for example, results in a similar way, with either using formula or this part of the ribbon. So let's say I will use results for bars, then let's say bar forces, and then I will use insert the formula in Excel. So let's say I want to import data of my moment for bar. So for each bar we have imported, then not in the middle, but let's say at the beginning of the bar. So I will specify 0 here, and we can see and activate the units, and then after selecting the fields here, I can expand it, and now program reads the data. So this is the easiest way and the fastest way to get results without any knowledge of programming languages, without using Ctrl+C, Ctrl+V options, copying by clipboard from Robot to Revit. If the Results Connect tab is not available in Excel, check whether add-in has been added in the active add-in section in Excel options. It's located under the File menu in Excel. If the Results Connect is not the active add-in section in the Excel options, select COM add-ins in the Manage drop-down list, then click Go and check the checkbox Results Connect in the next dialog box. Then click OK to make it available in Excel. Let's talk about Robot API. What's an API? API is an application programming interface, and this is a set of routines, protocols, and tools for building software applications. An API expresses a software component in terms of its operations, input, output, and underlying types. API make it easier to develop a program providing all the building blocks. A programmer then puts the blocks together. Robot has API implemented, so it's easy to get third-party add-in or application connected with it. Robot API documentation examples tutorials are installed as software developer kit installations together with Robot, either with Robot installation by the button Install Tools and Utilities and then selecting SDK, or it can be run directly from media from the folder shown on slide. After installation, Software Developer Kit is available from the Robot group in Windows Start menu. As you can see, besides the documentations, the samples and tutorials can be found there. How to start? In any programming language, it is required to set a robot object modeler with the highest version number one can have. And that's all. Then the programming can be started. On this presentation, we will focus on the simplest programming environment, which is VBA, Visual Basic for Application, in Microsoft Excel. To access VBA from Excel, the fastest way is to press Alt F11 keys on the keyboard. Reference can be added as shown on this slide from the Tools menu, then References, and selecting Object Modeler with the highest number. Remember not to select Robot Kernel Object Modeler. It's important note, Robot API uses SI units, so all data should be entered in these units. The same for results. Results are got by API in SI units. And here you can see very simple code. So first of all, we have to declare the object which is called robot application. Then we have to create such objects, and then we can start to play. This is a small hint how to check whether the robot is running. You usually do it by visible parameter. So whether if the visible is set to null, false, it means a robot is not running. When typing, program will give us hints by expanding programming tree to easy input data. To check correct data type which method returns, press Ctrl-I or on keyboard. I will show it in a minute. So let's go to example. Not yet, sorry. For those who want to develop add-in for robot, it's possible to add add-in created as exe or DLL file to robot menu. To do so, it's required to use add-ins manager from add-ins menu. Then after opening the add-ins manager window, we have to specify or show the path to the file and open it, and it will be automatically added to add-ins menu. But the limitation is that item can be added only to this menu. It's not possible to add our add-in to any other menu than add-ins. How to make add-ins as DLL files? These detailed procedures can be found under these links. First from C# and another procedure for VB. How to accelerate access to robot data? Create add-ins as DLL files instead of exe files. Access to robot this way is 5 times faster than by ordinary exe file. For much faster creating nodes and bars, cache can be used. After creating nodes and bars in cache by addNode or addBar methods, use apply cache to flash this data to robot in one fast step. How to accelerate creating, modifying panels, contours, lines, and other geometrical objects. Before, use begin multi-operation and multi-operation methods. Before code playing with this object geometry, use begin multi-operation, and after the end of such code, use end multi-operation. How to accelerate creating, modifying model, loads, etc. Set interactive flag as false, and then in the beginning of the code to minimize interactions with graphical user interface and refreshing display by API. How to accelerate access to robot data? In case of large models and large number of data we want to retrieve, it's recommended to use get collections, create collections, and then also use get whole servers like node server, bar server, result servers, reaction servers. Another way of accelerating retrieving robot results. Use query mechanism. Examples can be found under the links on forum. Here is the simple code for creating country level of uniform load. So at the beginning you can see that all the declarations, checking whether the robot is running or not. Here we can see the code for creating nodes, these two nodes, then creating bar with the two nodes, node number one as beginning node and node number 2 as end node, and applying some properties, some labels. So for node number 2, the code applies fixed support. For bar number 1, the section HEA100. Then we can create a simple case here and add load record, uniform bar load record with value of 20 kilonewtons for this bar. So that finally we got such model. So look at the code and how to use or type, create the code. Okay. So in Excel we can add the button, then we can activate the button and code under the button, or we can access VBA editor by pressing Alt F11 keys or keyboard. So we can now look at the live code and let's create a few lines of the code. For example, I will create the line for creating of node number 2. So first of all, after creating the object robot application, so this is the main branch of our coding. So I will use this object, then program will automatically shows us possible methods, functions, so structure. So under the application, under the object, we can go to the project. Then under the project, we can see different objects, servers, etc., etc. So I will create the structure. So under the project, there will be the structure branch. Then, as you can see, different branches here. So in my case, I will use nodes, then create, and then if it's not highlighted, I mean not expanded, it means this is kind of the end of the tree. So either by pressing Ctrl I on keyboard, we can see what we can get or we can set, or by just typing, for example, create once again. After pressing space, it should be also highlighted. Hint can be displayed. So let's type again the coordinates. How to play with different attributes. Usually we apply attributes, okay, too many commas. We apply attributes by labels in the same way as in robot. So how to play with the labels? Okay, I will add label, bar label. So object robot, then project, then the structure, then bars, and let's say for bar number 1, I will set the label, and then after pressing space, we can see the selection of different labels. So in our case, I will select section label, and then we have to specify label by string. So let's say I will use, as previously, HEA100 section. This is the code for creating simple case. So case name, case number, case name. So let's make a hint. create simple, and now we can see what is required. So then case number, name as a strings, then we can select natures by these enums and the analysis type. For each case, we can add or create records. So in our case, for the case number 1, which is set here, we are adding load record, bar uniform load record, and adding some value. In many records, you may see that some data must be set by set value method, and using this set value method, we have to use value ID and value itself. If it's not displayed as a hint, these enums are IDs, we have to find them by our own. For example, in help, which is under F2 button on keyboard. So we can select the library, and then we have to enter the string we required. So let's look at the code. I used the enum for bar uniform. So usually the enum contains the first letters of different options. So for example, in our case, this enum is bar uniform record value. That's why we have these 4 letters. So I will type this bar uniform record value here, just to show you what we can set. So it's exactly the same fields we can input and set the data as we set during creation of such load in robot. If the value of such member is not set, program automatically will set the default value. Usually zeros are set if not set by code. So using this enum, we can fill it as under the set value and then specify the value. In our case, it's 20,000. It means 20,000 newtons, 20 kilonewtons. And then running the code, either we can go back to our sheet and press the button I created, or pressing F5, we can see the effect in the robot. Oops, sorry. I will start again. Okay, once again. And now you can see our bar is created, support added, created case, and we can see the loads we applied. Let's go back to our presentation. Some add-ins and macros already developed and publicly shared are available on our forum under these links. So you can easily access them, download, and use, modify. Let's talk about Dynamo. What's then Dynamo? Dynamo is an open source visual programming extension that allows you to manipulate data, create geometry, explore design options, and automate process, create multiple links between applications. So to install Dynamo, it's required to go under this link and download Dynamo. Then the package, after starting Dynamo, the package must be found, robot structural analysis package must be found, downloaded, and installed. After this procedure, we can see additional item in the library under the branch of Analyze. We can find the robot structural analysis, where we can see the loads, model results, so we can access build data using these items. Here's the same Dynamo so-called code to create the same beam as it was done before with robot API in Excel. So this is kind of the graph. We can connect by the links and then see the same effect. We will make a short presentation how to play with Dynamo. So let's go to Dynamo. I will start new work set. So this is the Dynamo environment. So to play with robot, we have to go to Analyze. To create the model, we have to look in the model branch. So to create one bar, first we need to create nodes in a similar way like in API. So I will create node by point, another node. So to have one bar, we have 2 points, beginning and end. So we need to specify the point. So we can make double click and then type the point command. Then let's say by coordinates and specify the coordinates. So it will be, let's say 0, 0, 0 coordinate. Okay. And then we can connect it by dragging this link here, like that. In similar way, I will create another point. Wait a moment, something is not alive. So I'm afraid I have to restart the Dynamo. Let's start the Dynamo. Wait a moment. Okay. Dynamo is starting. Okay, so I will load prepared example just to not lose much more time. So it seems that unfortunately Dynamo stopped working for us for this presentation. So I guess I will explain what I wanted to show on the videos we already have in our presentation. So let's go to the presentation. So using the Dynamo, we can perform iterative analysis for better decision making in geometry size of our structure. So let's start the video. So this is the very similar code. So as you can see on the left hand side, we are creating nodes, adding additional properties to them, also creating bars using these analytical nodes. Of course, it's also possible to add code, usually by Python. So you can make loops or make looping in some areas. So here you can see in the code block the loop, while loop. So we can, or it's also possible to play with the lists instead of loops. So it depends how skilled we are in the Dynamo. And as you may see, now we will run this code and see the effect in robot. So this code generates the truss. Then we can calculate it, and depending on different criterions, we can change the sizes of, for example, bar sections. So as you may see, this section was changed. So using the results column, we can also get some results, make some diagrams in Excel. Besides generating structures in Revit, Dynamo can be also used in combination with robot structural analysis for generating models directly in RSA. Look at the responsive behavior of the structure when changing parameters with Dynamo Canvas. So I will start another video just to show you how flexible and how fast the Dynamo is. So to see the interaction, live interaction, instead of fixed numbers, we can use the sliders inside the Dynamo, and changing some data by sliders, we can see almost immediate changes on our structure in robot. Of course it's required to set run automatically code in Dynamo. So let's look at the left bottom corner of the Dynamo. So it's checkbox run automatically is marked. So every change in the code, well, let's say by sliders, can be automatically updating the model inside the robot. Structures engineers often want to push the calculation design a bit further than only a simple static calculation. Analysis software is not defined to handle thousands of different configurations. Dynamo is not limited to its out-of-the-box functionality. Dynamo community contributes to the functionalities by publishing custom packages. The Optima package makes use of genetic algorithms to generate new values from initial population values. The parent-child relationship, in fact, using Dynamo as the central canvas, robot structural analysis as the calculation engine, and Excel as the post-processing tool, you can get ideal recipes for structural optimization principles. So here we can look at an additional video how to play with Dynamo. And using this code and this video, we will see how to create, for example, truss bridge. So by connecting different items to correct places, we can see immediate visualization of the geometry inside the Dynamo, and then the same model can be exported to robot. So different items now connected. And then we can see this bridge inside the robots. So after making some modification in the sliders, you may observe immediately the changes, the differences between the models in robots. And of course, it's possible to run calculations inside from the Dynamo. Some hints. Dynamo is intended to be a way of creating parametric models, loads, and running calculations. It's not possible to get any results from robot by Dynamo. Dynamo for robot uses 3D system of coordinates, so in robot it's required to have or start the project with the structure type such as building, 3D frame, or shell. Code running direction in the Dynamo is from the left to right, so we have to properly place our items on the Dynamo environment to make it running from left to right. To obtain structure visualization in Dynamo environment, create nodes by points, not by coordinates. General Dynamo website and all the documentation you can find under these links. After installation of Robot Dynamo, you can find examples on your hard disk under the paths given on this slide. Thank you for attending today's webinars, and I would like to introduce and ask for questions, if you have any, related to these topics in our question and answer session now. So please fill all the questions you have in the questions field in GoToWebinar window. There is a question about creating this cantilever beam in the Dynamo, but as the Dynamo is hanging on my computer, I will send the video, which is already recorded, to any of you interested. So please contact me on the forum.
Rafał, maybe we could just include that in one of the next webinars. I mean, in addition to the topics, we can just return to the demonstration of Dynamo and show your example. What do you
So
think?
maybe additionally, because the video, as far as I remember, is recorded on the AUTODESK Chronicle. So maybe together with the posting of the webinar, I will give the link to this video on our webinar thread in forum. And Stefano is asking about the possibility to create DLL of VBA. No, it's not possible. It's internal, let's say, language which is inside the Excel or Word or any other Microsoft application. So to create exe file or DLL file, you have to use a proper environment like Visual Studio. As a question about updating results in robot by let's say external application, it is not possible to update results. You can update any kind of the data, geometrical data, loads, whatever, but it's not possible to update results. So results can be only retrieved from robots. They cannot be updated by any third-party application, neither for finite element calculations nor for any kind of design. There is a question about using API in terms of concrete design. Unfortunately, there is, concrete in the meaning of the provided reinforcement design is not implemented API for this, for any of the provided reinforcement module, provided reinforcement object design is not implemented in API, so you cannot access, set, or run in an automatic way the RC design. What to do with the results connected if it's not available in Excel? If it's not available in Excel, you can find additional installation either on the media under the link I shown. Wait a moment. So you can, okay, it's not here. So the separate installation is available either on our forum, on one of the threads. If you cannot find this results connect installation on forum, please contact us and we will send you results connect installation. The question about using cache, yes, the cache is much faster for creating bars and nodes only. So let's go back to presentation of API. Wait a moment. So where's, yeah, I hope it should be refreshed now. Yeah, this is the code for the cache. So let's look at it in our VBA environment. So to activate or to use the cache, so we have to use object project structure, then create cache. So up project structure. So here is the method to apply cache and then create cache. And create cache, you can only use add bars and nodes, and you can set some labels for these nodes and some labels for the bars only. So in case of playing it, so the idea is that you can create the geometry bars and nodes inside the cache memory, then using the apply cache method, all the data, geometrical data of nodes and bars, it's in a fast way exported to robot. So it's much faster than creating one by one each node or each bar in robot. So the question, what is the best way to implement something for local codes? As I stated in this presentation, to have a much faster and reliable, let's say, access to robot results and data, I would recommend use DLL files or at least exe files, depending on number of results you want to retrieve in one run and for how big models you want to do it. But using DLL files, it will be, as it was stated, 5 times faster than exe files. So you can prepare your own application in Visual Studio and then connect it to robot for retrieving all the data you need, results you need, and then perform design in your own code and present the results in your code or in your environment as you like. If there is no other questions related to these topics, I would like to thank you for attending this webinar. And invite you for the next webinar, which will be held on 13th of January 2016 year, and its topic will be Robot Revit interoperability. Thank you for attending this webinar.